G'day, I'm the Home Distiller, and today we're going to finish off the backing plate for the 165mm chuck on the C6 Sieg Lathe. There was a few problems along the way with the crappy tooth belt in the back of this lathe slipping it when I was trying to go on low RPMs. That'll be another mod down the track to replace that with a V-belt. And also I have a DC motor from a treadmill with a speed control that will be going on here. We had to use just a plain old hole saw to knock out the slug, which you can see is still stuck in there, out the centre of the billet that I cast. That worked not too badly. Had to go slow. Did overload my mill a little bit. But we got there in the end. We managed to get down to 0.02 of a millimetre of total indicated run out on this chuck, which is the same as my small chuck after I recalibrated it. So we've got the same kind of run out on both chucks. Now I'm not sure if it could be that run out was actually in the bar that I was using. I was using a piece of shafting out of a gearbox, so it does have a bit of wear on it, but it should be fairly straight and smooth. What else? We had to modify some cap head bolts because I needed the cheapies off eBay, stainless steel. Didn't want to order and wait for any more, and I've got a whole heap, so we just modified them. There was a couple of little boo-boos along the way with some holes that got drilled slightly crooked, but it didn't matter in the end. Because they were all slightly skewed the same direction, they all lined up. We'll get to that. Yeah, so thanks for watching. Let's get to it. First we're on the mill, boring that hole out so we can chuck it up in the lathe. Well, that was a success. More than I thought it would be anyway. Okay. All right. side. Let's work on facing it off. Okay, we're at 122 millimeters, so we're almost there. almost overshot then. Alright, let's just do, that's not an important dimension, that one, so let's just clean that up. Okay, well, time for the next diameter. Which is 95. Okay. There's a wee bit of wiggle in that, which isn't ideal, but this is still pretty warm, and when it shrinks that should hopefully disappear. So next we're going to, it's cooled down and it's getting, there's no play in it at all anymore, so we'll mark the holes and we'll drill and tap them, I think. Alright, welcome back to the bench from hell, one of the many in my workshop. You really need to clean this place out. And you can see we've got a pretty good fit in there. There's a tiny bit of play in it, but yeah, that wouldn't really, I mean, I'm going to have to adjust the chuck once it's all mounted anyway, so I'm not overly concerned. This mating, once it's all bolted down, she'll all be straight and true, so and once this is bolted down and I'll try and machine another boss that'll index on the inside there, and that's the one that's important. So yeah, hopefully we can get that nice and accurate. So for this one, I'm going to transfer punch these holes and then drill and tap them. Now the problem is that's a very, very tight fit. I'm going to ignore that mark, and because getting it out is getting this punch out, I don't know why that's, it's almost like these holes are slightly tapered. Interesting. But I think we'll clamp that together. And then it won't matter if it decides to jam it on. That one, that one, that one, and that one. Okay, we've got to set up in the lathe again because we need to machine this face. So we have a parallel surface to the back, so we've got a datum to drill our holes nice and square. So let's just face this off. Okay. So now we have a nice surface to machine to put in the mill. Okay, that's that hole found. We've got a 7mm drill. say you shouldn't do this with a straight flute tap, but it is only aluminium. And I've never had a problem doing it with aluminium.